Hi everyone, I'm Math Noah. In this video, we discuss three different methods of checking if an integer is a multiple of 3 or not. Method 1. Dividing the integer by 3 to see if there is any remainder. If there is no remainder, this means that the integer is a multiple of 3. If there is, this means that the integer is not a multiple of 3. Let's take 852 as an example. Let's see if it is a multiple of 3 or not. We are going to divide 852 by 3. Let's see how we work it out. For long division, we always start with the leftmost digit. In this number, it is 8. How many 3 can we take out from 8? The answer is very simple. We can take out 3 2 times from 8. Taking out 3 2 times from 8 means taking out 6 from 8. Therefore, we write 3 times 2 equals 6. After we take out 6 from 8, the remainder is 2. 2 is smaller than 3. However, when 2 works with the next digit, we can form a number that is larger than 3, and we can take out certain number of 3 from it. The next digit is 5. We bring it down here to work with 2 to form 25. How many 3 can we take out from 25? The answer is very simple. We can take out 3 8 times from 25. Taking out 3 8 times from 25 means taking out 24 from 25. Therefore, we write 3 times 8 equals 24. When 24 is taken out from 25, the remainder is 1. 1 is smaller than 3. However, when 1 works with the next digit, we can form a number that is larger than 3, and we can take out 3 several times from it. The next digit is 2. We bring it down here to work with 1 to form 12. How many 3 can we take out from 12? The answer is very simple. We can take out 3 4 times from 12. Therefore, we write 3 times 4 is 12. When 12 is taken out from 12, there is no remainder, and we have finished our division. When 852 is divided by 3, the result is 284, and there is no remainder. This means that 852 is a multiple of 3. Method 1 is easy to understand, but tedious to do. Method 2. Adding up all the digits of the integer to form a checking number. If the checking number is a multiple of 3, the integer is a multiple of 3. If the checking number is not a multiple of 3, the integer is not a multiple of 3. Look at the 5 integers. Only one of them is a multiple of 3. Let's use method 2 to find it out. For each of the integers, let's work out the checking number first. For the integer 668, the checking number is 6 plus 6 plus 8. It is 20. For the integer 468, the checking number is 4 plus 6 plus 8. It is 18. For the integer 122, the checking number is 1 plus 2 plus 2. It is 5. For the integer 937, the checking number is 9 plus 3 plus 7. It is 19. For the integer 434, the checking number is 4 plus 3 plus 4. It is 11. Of all the 5 checking numbers, only 18 is a multiple of 3. By method 2, we know that 468 is a multiple of 3. Method 2 is easy to do, but difficult to understand. Why can we use the tracking number to determine whether the integer is a multiple of 3 or not? These were my questions when I learned Method 2 from my mathematics teacher long time ago. I will give you an explanation of this method at the end of this video. When I was using Method 2, I came up with an innovative way of modifying it, and the modified version is Method 3. Before I let you know the details of Method 3, I'd like to tell you a role play that I had in my mathematics class recently. 2 students helped me in the role play. I asked the first student, "How much money do you have?" And the student replied, "I have 7 euros. I said to the student, 7 is not a multiple of 3. I want to help you. Let me give you some money to see if I can help you change your money to be a multiple of 3. Before I pretended to give money to the student, I also told the student that there was a rule in my family that I might give money to others. However, I could only give either 3 euros, 6 euros, or 9 euros, and I could not give any other amounts of money to others. Then I walked up to the student and pretended to put 3 euros on the desk. I said to the student, "Now you have 3 more euros. See if your money is a multiple of 3 or not." 7 plus 3 is 10. 10 is not a multiple of 3. Almost all students in the class replied to me that, "No, it didn't help." Then I pretended to get back the 3 euros. And again I pretended to put 6 euros on the desk. And I said to the student, "Now you have 6 euros more. See if your money is a multiple of 3 or not." 7 plus 6 is 13. 13 is not a multiple of 3. All students said no, it didn't help. After they said no, I said to the student, "Don't be worried. I still have 9 euros in my pocket. I will give you all. Let's see if it helps." But the students still said no, it doesn't help. Do you understand why I could not help the student in the role play? The student has 7 euros. Let's put a mark here. Notice that on this number 9, each solid dot represents a multiple of 3. Also notice that the red arrow is 1 unit on the right of a solid dot. Now I add 3 to 7. I simply move the red arrow forward by 3 units. The red arrow is still 1 unit on the right of a solid dot. In the second attempt, I gave 6 euros to the student. Actually, adding 6 to a number means adding 3 2 times to the number. Let's see what happens. Adding 3 the first time. Adding 3 the second time. The red arrow is still 1 unit on the right of a solid dot. In the third attempt, I suggested giving 9 euros to the student. Actually, adding 9 to a number means adding 3 to the number 3 times. Let's see what happens. Adding 3 the first time. Adding 3 the second time. Adding 3 the third time. The red arrow is still 1 unit on the right of a solid dot. It is not difficult to observe that no matter how many times of adding 3 to 7, the red arrow will always be 1 unit on the right of a solid dot. Generally, for an integer that is not a multiple of 3, no matter how many times of adding 3 to it, it is still not a multiple of 3. Let's go back to the second part of the role play. Before the role play, I told my students that everything I said was not real, and I asked them not to take it seriously. I asked the second student how much money the student had. The student answered 12 euros. I said 12 is a multiple of 3. However, I don't like you. I want to give you some money to try to make your money not a multiple of 3. I walked up to the student 3 times. The first time, I gave the student 3 euros. The second time, 6 euros. And the third time, 9 euros. Each time after the student got my money, the student's money was still a multiple of 3. At the very beginning, the student's money was 12 euros. Let's draw an arrow here. Notice that the arrow is on a solid dot. Now I add 3 to 12. I simply move the arrow forward by 3 units. The arrow is still on a solid dot. In the second attempt, I give 6 euros to the student. Actually, adding 6 to a number means adding 3 2 times to the number. Let's see what happens. Adding 3 the first time, adding 3 the second time. The arrow is still on a solid dot. In the third attempt, I give 9 euros to the student. Actually, adding 9 to a number means adding 3 times to the number. Let's see what happens. Adding 3 the first time, adding 3 the second time, adding 3 the third time. The arrow is still on a solid dot. It is not difficult to observe that no matter how many times of adding 3 to 12, the arrow will always be on a solid dot. Generally, for an integer that is a multiple of 3, no matter how many times of adding 3 to it, it is still a multiple of 3. After the role play, we understand that whether an integer is a multiple of 3 or not has nothing to do with adding 3 to it, no matter how many times. In other words, no matter how many times of adding 3 to an integer, we cannot change whether it is a multiple of 3 or not. Method 3. Forming a smaller checking number by skipping the digits 3, 6, and 9. Do you remember these 5 numbers? For each of them, let's check again whether it is a multiple of 3 or not by method 3. Look at this integer. By method 2, to form a checking number, we have to do 8 plus 6 plus 6. However, we know that 8 is not a multiple of 3, and this won't change after we add these two 6 to it. Therefore, there is no point in adding these two 6 to 8. We simply don't bother to do it. The checking number is 8. Look at this integer. By method 2, to form a checking number, we have to do 8 plus 6 plus 4. However, we can choose to do 8 plus 4 plus 6. 8 plus 4 is 12. 12 is a multiple of 3, and this won't change after we add 6 to it. Therefore, there is no point in adding 6 to 12. We simply don't bother to do it. The checking number is 12. Look at this integer. By method 2, to form a checking number, we have to do 2 plus 2 plus 1. However, 1 plus 2 is 3. What's the point of adding 3 to this 2? We simply don't bother to do it. The checking number is 2. Similarly, for this integer, we simply omit 3 and 9, and the checking number is 7. For this integer, to form a checking number, we omit 3, and the checking number is 4 plus 4, and it is 8. Of all the 5 checking numbers, only 12 is a multiple of 3. Therefore, 468 is a multiple of 3. Notice that it is a lot quicker to use method 3 to check if an integer is a multiple of 3 or not. It takes me less than 3 minutes to check all the 63 integers here to see if each of them is a multiple of 3 or not. On average, each integer takes me less than 3 seconds to check. Let me circle 3 integers that are multiples of 3. Look at this number. It is 246. I simply omit 6. 2 plus 4 is 6. 6 is a multiple of 3. So 246 is a multiple of 3. Look at this number. It is 195. I omit 9. 1 plus 5 is 6. 6 is a multiple of 3. Therefore, 195 is a multiple of 3. Look at this number. It is 597. I omit 9. 5 plus 7 is 12. 12 is a multiple of 3. Therefore, 597 is a multiple of 3. If you understand the concept of method 3, you understand the concept of method 2. Let's take 582 as an example to explain the concept. 582 can be written as 500 plus 80 plus 2. 500 can be written as 5 times 100. 80 can be written as 8 times 10. Therefore, the expression can be changed to 5 times 100 plus 8 times 10 plus 2. 100 can be written as 99 plus 1. 10 can be written as 9 plus 1. Therefore, the expression can be changed to this. To remove this pair of brackets, we have to do 5 times 99 plus 5 times 1, that is 5. To remove this pair of brackets, we have to do 8 times 9 plus 8 times 1, that is 8. Therefore, this expression can be changed to this. 99 can be written as 11 times 9. This expression can be changed to this. Notice that we have 5 numbers here. 1, 2, 3, 4, 5. When we add up all these 5 numbers, we have 582. You can use a calculator to check it. Also notice that 2 plus 8 plus 5 is 15. 15 is a multiple of 3. You may say, we need to add these 2 numbers as well. However, to add this number means to add 9 8 times. What's the point of doing it? Similarly, to add this number means to add 9 55 times. What's the point of doing it? Actually, what we need to do is add up the 3 numbers only. Finally, do you notice that this number comes from this digit? This number comes from this digit. And this number comes from this digit. This explains the concept of method 2. Thank you for watching this video. I wish that you will find it useful. If you do, please share the link with your friends and recommend it to others.